Okay, so we are going to look at solving systems of nonlinear equations. We will have some of the same methods as before. We could solve with graphing, we could solve with elimination and substitution. However, we will have a few more limitations on those depending on the system we're given. So in the first one, what this is, this x squared plus y squared equals 100, that's actually the graph of a circle. And then this 3x minus y equals 10 is a graph of a line. And so this one's, I kind of know what's going to happen here. It's going to be a line through this circle, and these intersection points will give you the solution. And you won't necessarily know that before you graph it, but this is the similarities, or before you solve it, but this is the similarities between the other solutions of just lines, is we're looking for intersection points. In this case, it could be that there are two. We could create an example where there's one solution or no solutions as well. As you look at this graph, as you look at this system, you'll notice that we can't use elimination because I have an x squared term and an x term, so I can't add those together. And then I have a y squared term and a y term, and I can't add those together. So we have to use substitution. So to solve this with substitution, I'm going to solve for this y down here. And let's subtract 3x from both sides. And then divide by -1 to get y is equal to 3x minus 10. And then with substitution, I substitute or replace the variable with whatever the expression is. So in this case, I'm going to go up to my top equation, the equation you didn't use, and plug in 3x minus 10 in for y. And so you just drop it in there and rewrite the equation. And then you have an equation you can solve. You may look at that and say, well, it's not going to be too fun to solve, and that's fine. It will take a little bit of time, but we can solve this, and this one works out pretty nicely, actually. Remember not to distribute the squared, but you must FOIL here. And so we get x squared plus 9x squared, and then minus 30x minus 30x, we'll just make that minus 60x. Save us a line here. And then plus 100 is equal to 100. And we notice it's quadratic, so we're going to get all of the terms on one side of the equation and see if we can solve. So let's combine like terms, and I get 10x squared minus 60x. And then when I subtract 100 from both sides, that goes to 0. So that's nice. That makes the factoring much quicker. And so now I can factor out a 10x, and I'm left with x minus 6. And then these are multiplied, so we know we can set both of those equal to 0 to find two solutions for x. So x is equal to 0, and we'll go ahead and start an ordered pair. Oops, let's put 0 in there. And then x is equal to 6. Okay, now we need to find y, and we can use any equation to find y, the top or bottom, or even one that we've already manipulated. So since this is already solved for y, let's use that guy to find y. So I'm going to do it twice. I'm going to plug in 0 for x. You can maybe do this in your head, but we'll write it down to find y is equal to -10. And then let's plug in 6 for x to find y is equal to 18 minus 10 is 8. And so now we have two solutions. We have 0, -10, and 6, 8 for that first system. And those solutions will both make the equation true. So we do have a situation where the circle hits the line in two spots. Okay, let's go on to number 2. Number 2 is set up where we could use elimination, and that's what we'll do here, because if I add these together, I can add these x squared terms, I can add the y terms, and I can get something to cancel. Let's go ahead and get the get rid of the x squareds. That makes for a neater equation down the line, down the road. So I'm going to multiply this by -5 up top and then just 3 on bottom. And then when you do this, rewrite the equation. Don't take like a shortcut and don't rewrite it. So you get -15x squared minus 10y is equal to, and then let's see, I need -5 times 26. Which is -130. And then 15, oops. On the second equation, we get 15x squared and then minus 21y, which is equal to 9. And then when I add those together, I get, let's see, did I miss it? This should be positive 21. So those add to 0 here, those are gone. I get 11y here, and then -121. And so y is equal to -11. And then we can use either equation to find x. I can use the top or bottom. If I use the top equation, it would give me 3x squared plus 2 times -11 is equal to 26. And then that gives me 3x squared minus 22 is equal to 26, or 3x squared is equal to, when you add 22, you get 48. And so x squared is equal to 16. And then when we know when we're solving, if I take the square root, then I have those two solutions, the positive and negative. So x is -4, and then x is positive 4. And we already know y. So y is always -11. But we do have these two solutions. We have -4, -11, and then 4, 11. And so both of these equations make, or both of these ordered pairs make both of these equations true.